Hi everyone, in this video we will see how we have to construct syntax tree and how we have to optimize that. Okay, that is a DAG for a given expression. Here we are having an expression a equal to b into minus c, that is unary minus c, plus b into unary minus c. So how we have to construct syntax tree and DAG for the given expression. So before constructing syntax tree and DAG, we have to write three address code for this. Okay, here we are having b into c minus c plus b into minus c. So while scanning input from left to right, okay, here which operator having higher precedence means first unary operator minus c. Okay, so first we have to write code for this, three address code for this. So first we have to write three address code. Okay, so first code is what? Minus c. So using temporary variable we have to write three address code for minus c. So I store minus c into the temporary variable t1. Okay, next scan the input from again left to right. Here we are having b into, what is this? t1. b into t1 plus b into minus c. Okay, so which one having higher precedence means here star. Okay, so first write code for b into t1, t2 equal to b into t1. Okay, so this part over. Okay, again scan the input from left to right. Okay, now we are having t2 plus b into minus c. Here if you want to evaluate star means first you have to write code for the unary operation. Okay, so use another temporary variable t3 for the unary operation. Okay, so t3 equal to minus c. Okay, and then perform the second of b into minus c. b into, what is minus c? Minus c is stored in where? t3. Okay, so b into t3. Okay, so b into minus c plus b into minus c. Okay, then we have to add t2 plus t4. Okay, so using one new temporary variable t5. Okay, add that two variable t2 plus t4. Okay, then we have to store the entire term result into where? A. Okay, now this entire term is called as t5. Okay, so assign that into variable a. Okay, so a equal to t5. This is a way for writing three address code. Okay, then we have to construct syntax tree. Okay, so how we have to construct syntax tree for this means, what's the first variable? t1 equal to minus c. Here what's the operation? Operation is what? Unary minus. Okay, then we are having only one operand c. So for that we have to construct unary u minus, that represents unary. Okay, unary minus of what? c. Here we are having only one operand, no left, no right. Okay, it's here we are having only one thing, unary minus c. Okay, it's over. This part is called as what? t1. This part is called as what? t1. Okay, next we have to construct tree for t2 equal to b into t1. How we have to construct it? Already we are having t1. Okay, t1 b, here we have to add where? Here. Okay, add it here, otherwise write it here, b into what? Unary minus of c. Unary minus of c. Now the result is called as t2. This result is called as t2. Okay, then again construct t3 equal to what? Minus c. So like that, u minus of what? c. u minus of c. t3, that is called as what? t3. That is called as t3. Okay, and next we have to construct t4 equal to b into t3. b into, what is? t3. Okay, this is called as what? t4. b into t3. Okay, that is called as t4. Okay, and next we have to construct T5 equal to T2 plus T4. Here we are having T2, here we are having T4. Okay, so T5 is T2 plus T4. T2 plus T4 equal to what? T5. Okay, next we have to assign A equal to T5. A equal to T5. That's all. So this is syntax tree for the given tree address code. Okay, next we have to optimize it. Okay, how we have to optimize it? Optimize it means we have to check whether the variable or data is already declared or not. Okay, if it is already declared and defined means we can use that. Okay, next we have to check whether the sub expression is already evaluated or not. Okay, if it is already evaluated and the values are not changed means we can use already calculated value. Okay, so that is called as optimization. That part, that syntax tree optimization is called as DAG. Okay, so how we have to optimize it? Okay, here first check it, the tree address code. Okay, optimized code, optimized, this is next one, optimized tree address code. Okay, here first thing is what? T1 equal to minus C. I just consider that because it's not already defined. What's the next statement? T2 equal to B into T1. Okay, just consider that because this statement is not evaluated already. Okay, then next one, T3 equal to what? Minus C. T3 is already evaluated. T3 equal to minus C. That is already stored in where? T1. Okay, so no need to again store the same variable into another temporary variable. You just ignore the statement. Okay, so ignore T3. Ignore T3. Then come to next statement. T4 equal to what? B into T3. What's the T3? T3 equal to minus C. So instead of the T3 we have to use what? T1. So here what's the statement? T4 equal to B into T1. Already B into T1 is evaluated and stored in where? T2. So ignore T4. Ignore T4. Okay. Then come to T5. What is T5? T5 equal to T2 plus T4. We ignore T4 because the T4 points to what? T2. T3 points to what? T1. We already ignored T3 and T4. So instead of T4, here what's the statement? T5 equal T2 plus T4. Instead of the T4, we have to call T2. We have to call the variable T2. So how we have to write the code means T5 equal to T2 plus what's the T4? T4 points to again T2. So T2 plus T2. Okay. Then assign A equal to T5. So this is called as optimized tree address code. Optimized tree address code. Okay. Now we have to construct syntax tree for this. Okay. How we have to construct syntax tree? That optimized syntax tree is called as DAG. Optimized syntax tree is called as what? DAG. Okay. So how we have to construct? What's the first statement? T1 equal to minus C. Okay. So minus, otherwise I will write it here, minus unary minus C. Okay. Then this is called as what? T1. This is called as T1. Okay. Now T2 equal to B into T1. Okay. So B, variable B into T1. B into T1. That is called as what? T2. That is called as T2. Okay. And next T5 equal to T2 plus T2. T5 no? T5 equal to what? T5 is T2 plus T2. This is called as what? T5. Okay. Next we have to assign A equal to what? T5. We have to assign this result into variable A. That's all. Okay. So now this is called as optimized code. Okay. Here This is normal syntax tree. Here T1 equal to what? Unary minus C. T2 equal to B into T1. Okay. T3 equal to unary minus C. T4 equal to B into this. T5 equal to T2 plus T4. Then A equal to T5. Okay. Here T1 equal to unary minus C. T2 equal to B into T1. T5 equal to T2 plus T2. Then A equal to T5. Okay. That's all. So this way of optimization will improve the compiler efficiency. Okay. Thank you.